and welcome to Need More Sleep, Rest Can Help. Okay, my name is Drew Branch. I'm an Associate Security Analyst at ISG. I hold a BS in Electrical and Computer Engineering, as well as a Master's in Cybersecurity. I love to learn about new tech and also break in it, and I love to play sports. Very competitive, hate to lose, that type of thing. So a little bit about ISG. We are based in Baltimore. We deliver high-end custom assessment results, or assessment reports, as you say. We also assess new web technologies, and from time to time we come across RESTful APIs. So this gave me the motivation to put together this talk. So I'll give you guys a little bit of background about REST, give you a comparison between REST and SOAP, as well as go over some REST concepts. Then I'll go over common security mistakes that developers tend to make when I come across these issues during assessment, and also how to fix them. So REST. REST stands for Representational Transfer State, or State Transfer, I'm sorry. It is a stateless client-server cacheable communication protocol. There are similarities between REST and HTTP because Troy Fielding, who defined REST, was also a main contributor of HTTP. REST also uses HTTP methods for all CRUD operations, such as create, read, update, and delete. So REST versus SOAP. There isn't a specification that defines REST. It's like no rules. It's easier to create documentation for RESTful APIs, scalable, as well as the RESTful APIs also make use of all HTTP methods. SOAP, on the other hand, uses the SOAP protocol to exchange data. It is bound by SOAP specification. So today you break one requirement, your API isn't SOAP anymore. And SOAP always uses the HTTP post method for all requests. So let's take a look at a couple sample requests. On the left, we have a RESTful request. As you can see here, I am submitting credentials to an endpoint using the post method, which is a REST request, which is pretty standard. On the right, we have a SOAP request. I'm using the post method because all SOAP requests require the post method. But within the body, it actually contains the operation. So in this example, I am submitting a post request, a SOAP post request, but I'm actually getting the stock price of IBM. So within the body of a SOAP request, it will contain the operation. So let's step into HTTP methods. We have get and post, which are pretty popular. Delete, which is used to delete a resource. Patch, which is used to modify the resource but not to replace. And put, which is used to replace a resource with an updated version or to create a resource. We have other methods such as options, head, and trace. There are many more. I just decided to list these few. Status codes. I just wanted to throw this in here because when you're testing RESTful APIs, you will come across status codes, whether good or bad, which gives you more information about whatever you're testing. All of these should be pretty familiar. Have 200 level, 400 level, 500 level, and also there's 100 level and 300 level. I'm not going to go too deep. So what's the data format of a RESTful API? There isn't one. A RESTful API can deliver XML, plain text, or JSON, whatever you want. So the next question is, how does the client or server know the format of the data? And that is the header content type. The client or server sends this header value, whether it's text/XML or application/JSON, telling the server or client what's the format of the data. And an API could return multiple data types, such as XML and JSON, or text and XML. So content negotiation. The question here is, how does the server know what the data format should be? The client sends the server and a subheader, which contains the preferred data format. Then the server either sends the data in that preferred format or error, saying, hey, I don't support this format, try again. So let's touch on resource URIs. There are two types. There's a static and there's also a RESTful. So here I am using a blog service, example.com/blog name is the blog resource. Each blog has a static web page. When you go to this URL, the web page will be delivered. Now, a RESTful URI is a bit different. Have the same resource at the same URL, example.com/blogs, which contains all the blogs that are hosted by that service. And then to access the blog, you will use the blog ID, which is just an ID generated whenever a resource is created. Now, it's better to use this second example because the URI stays the same if the web app is changed. And it's also independent of the framework. So it's best practices to use the second example when building out your RESTful API. So resource relationships. It's better to group resources that belong to another resource in a subfolder. So it is clear that, let's say, a comment of a blog, this comment belongs to a particular blog. So here we have example.com/comment/comment ID. This method puts comments in its own folder, and you access the comment by its comment ID. Sorry. This treats both blogs and comments as separate entities, and loses relationships between the blogs and its comments. Now, instead, these comments should be stored as example.com/blogs, the blog ID, and then within that directory, a comments folder should contain the comments for that particular blog, as you can see here in the second sample URL. Now, this method keeps the relationships between a blog and its comments. Keeps it more organized, simplistic. So let's go over a concept called HATOS, as I call it. I'm not too sure how to pronounce that. HATOS stands for Hypermedia as an Engine of Application State. This is a concept where the server sends the client URLs so the client doesn't have to deal with URL construction. Okay, let's see what this looks like. So here we have a sample response from a server containing the URI to the blog's comments as well as the author's profile. We also have other information such as blog ID, the author's handle or name, as well as the date that it was created. So you might be asking yourself, how do I know my API is RESTful? Is it fully RESTful, almost RESTful, or not at all? To determine this, we use the Richardson maturity model. Let's take a look at this looks like. So there are pretty much three levels. Level 0, saying, hey, your API isn't RESTful at all. It's pretty much so. So let's go through the other levels. So level 1 is the use of resources. So you would access a resource by its ID instead of having a static web page. But the request will also contain the operation to be performed. So say you make a request to get a blog, you will still use the post method, but within the request you will say get blog. Level 2 comes in when you start to use HTTP methods. Post, get, put, patch, as well as status codes. And your RESTful API will be of level 3 if you implement HATOS, hypermedia controls. Now, these are just guidelines. There are no strict rules to clearly define an API or RESTful API, just guidelines to like give you a general idea. So a couple useful tools is Postman. Postman is a Chrome plugin that developers use. I mean, I guess security assessors could use this as well. This is easier for developers to test their APIs. With a great UI, it's pretty good. Burp, as you know, is a great tool to assess APIs during assessments. So here's a screenshot of Postman. Like I said, the GUI is pretty nice. It allows developers to send all different types of requests. It also keeps a history, so you can go back and revisit and change parameters if you would like, and send different types of requests to your endpoints. Here's a screen of Burp. Burp is a web application test platform. It's comprised of several tools. For this talk, I will be using Repeater, but it also has functionality for you to fuzz things, as well as intercept and modify requests to and from the server. This tool is amazing. So a couple security concerns we have when we test RESTful APIs. Developers want to protect against unauthorized or unauthenticated modification of protected assets. They also want to protect against unauthenticated, unauthorized access to protected assets, as well as defend against replay attacks. For this talk, I created a sample API, it's a blog API. I use Eclipse with Maven. Maven is great. It pretty much downloads, package all of the dependencies for the project. I use Spring, which is a RESTful web service API to secure my endpoints, and Tomcat to host it. So how do we go about protecting our RESTful APIs? First, we can start by protecting HTTP methods. Okay. So not every method is for every resource. We should whitelist allowable methods, and we should not allow it's the delete method for critical files. Like users shouldn't be able to delete a particular file, for example. So what does this look like in Spring? You should annotate endpoints with allowable methods. Okay, here I append the method parameter here saying, okay, a GET request comes in to blogs, and my endpoint will return all blogs. Okay. And this is what it looks like in Jersey. Jersey is an extension of JAX-RS, which is a Java API for RESTful web services. Same thing here, I just annotated this endpoint with the GET parameter. So let's touch on JSON web tokens. I come across this more and more recently. People are using JSON web tokens instead of cookies. JSON web tokens are used to identify the sender, stateless, so it contains all the information needed to authenticate the user, as well as verify that the token is actually valid. It's in JSON format. It's base64 encoded. Since it's not a cookie, you can't secure a JSON web token with the usual security flags, such as secure and HTTP only. The actual token is sent in the authorization header. It's usually used for authentication instead of authorization, even though it's sent in an authorization header, but you could use it for authorization. So when a user logs in, the server checks the credentials. If everything is good, it'll create a JSON web token or JOT. Then for each request, the client will send this JSON web token with the request to authenticate itself and to verify the sender. So the web token is made up of three parts: the header, the payload, and the signature. The header contains the algorithm used to create the signature, as well as the token type The payload contains claims, a statement about the entity, usually the username, as well as metadata about the token, such as the expiration date, the issuer, and so on and so forth. So here's a sample job. Here we have the header. The algorithm used here is HMAC SHA-256, a type of token. It's a JSON web token. The payload contains the issuer, which is dbrand, which is me, the subject, which is its username, and the expiration date. Now the signature is computed by taking the base 64 of the header dot the base 64 of the payload, and then you HMAC SHA that or whatever algorithm you want to use, hashing algorithm, to create the signature. The format of a JSON web token is header.payload.signature. This is an example of one. It's the shorter version. These web tokens are much longer. So JSON web tokens should not contain any sensitive information because they're not encrypted. They're just basic support encoded. You could, although, encrypt your JSON web token using JSON web encryption. The secret used to create the signature should be secured on the server side because we don't want users to, forge their own JSON web tokens. So securing endpoints with JSON web tokens, we should verify the signatures, set a short expiration date, always communicate over a secure communication channel, and secure signing secret server side. Also, it should not include sensitive information. If you have to, encrypt your token. So let's send a request to our endpoint blogs, which returns all the blogs. Now notice I have not included the JSON web token in this request. And let's see what is returned. We receive all blogs from the server, which shouldn't happen. Right? The user isn't authenticated or authorized to view any blogs without a valid JSON web token. So let's go to the code. So for our endpoint, before the request is received by the endpoint, we should create some type of filter or interceptor that intercepts all requests and then verifies the JSON web token. In Spring, I created a filter which intercepts the web token, extracts the user information, and then validates the token. And then everything checks out, the request will be sent to the endpoint, and the response will be delivered to the user. So let's take a look at the validate method. So after the information is extracted from the token, the user is checked, and also the expiration of the token is checked. As well as if the user has changed their password before the token was created, it will send back an error saying, hey, you have to re-authenticate yourself because you changed your password after this token was created. So let's send the same request without a JSON web token now that we have implemented our filter, and we receive a 401 status code saying you're unauthorized, which is great. This is exactly what we want to happen because you don't have a JSON token in your request, so we want to send back an error and not the blocks. Now let's send a request with a forged JSON web token. Let's see what happens. We send a request. The server returns a 401 unauthorized response, just like we wanted to happen because the JSON token is invalid. Right? So we also want to protect sensitive resources. Now how do we do that? We implement access controls, either role-based or user-level based or a combination of both. So during assessments, I kind of come across applications where they are housed in a multi-tenant environment. So within this environment, you don't want to have clients accessing other clients' data. Right? This shouldn't happen at all. So we need to implement a permission level of some sort. So pretty much send an auth request, and I receive a valid JSON token. Username and password is user password. This is a user level account that I have stored in my API. Okay, let's get the blogs. So we have blogs. We have 3 blogs. dbrand created one, admin created one, and user created the other one. Okay, let's see if we can delete a blog. So we send a delete request wanting to delete the admin's blog. Remember, I'm a user level account, so I shouldn't be able to delete somebody else's blog. And I receive a 200 status OK, which shouldn't happen because I am not the author of that blog. And let's see what the code looks like. So here, you have an endpoint accepting the delete method. So what this endpoint does, it extracts the ID, it fetches the blog, and then it removes the blog. Here we have no access controls implemented, which should never happen. What the code should look like is this. We take the token, extract the user information, such as the username, as well as the roles of that user. Then I implemented a check here. I'm getting a blog as the author, and I'm comparing it to the username. If that checks out, the blog is deleted. If that doesn't check out, the second check is checked or verified. The permissions of that user is checked to see if it has role of an admin. I implement this because admin should be able to delete a blog even though it was created by something else or somebody else. If both of these checks don't check out, the error returns and you're not authorized to perform this action, which is what we want. So now that we have our access controls implemented, we send a request again, same request, delete request to the blogs /2 endpoint. And we return with you're not authorized to perform this action. This is exactly what we want. So input validation. The server should always validate incoming data. So always check the content type to make sure that the content type is supported by this endpoint. The server should never assume the content type. And the content type should always be checked. Content type should be JSON, then the data within that request should also be JSON and vice versa. If not, 400 level status code should be returned. Let's see how to do this in Spring. You can just add the consumes equals whatever data type you want within the actual endpoint. Now Spring automatically handles errors. So say you receive a request containing text /XML, the Spring will actually handle the error and send error message back to the client. And this is what it looked like in Jersey. So let's send a request to the server containing the content type text /XML and see what's happening. I am returned with a 415 status code saying, hey, unsupported media type, I can't read this type of data, go back and try again. Let's try to send the same request, but in this case, we change the content type to application JSON, which is supported by the endpoint, and see what happens. I'm returned with a 400 level request saying that, hey, the data format is incorrect. I'm looking for a curly brace, but I don't find it, so yeah, the data format is wrong. So output encoding. Security headers should always be sent with all requests. Within all responses, sorry. The content type should always contain the correct content type. So if the server is sending JSON, the content type header should include the application /JSON. Also, X content type options, no sniff should also be set so that the browser won't try to detect a different content type other than the one that is supplied. So with that, I'm going to wrap up my talk. That was pretty fast. My blog API will be available on GitHub. I partially based it off of an already working demo of Spring. Also, the presentation will be available on our company's website. And if you have any questions, you can ask now or send to my email. Oh, I also have a couple of drink tokens for tonight. So if you come to the Derby room and want to talk about RESTful APIs, you can. I'll give you a drink token.
I think last year, when it was given to me, I was very enjoying it. Exactly. I did in fact use it for a drink.
Oh, that part should have left it up there. Yeah, I can do that. Yeah, sorry about that. Got a big nervous